Hello everyone, welcome back to the brand new lectures in physics. So in the previous class we have dealt with the concept of rounding off, and at last I have discussed something related to accuracy and precision. So in this class we will discuss the concepts related to errors and its types. So before going to that concept, I just want to give some explanation related to accuracy and significant figures. So accuracy. I already said that if number of significant figures are more, accuracy will be more. So that means accuracy is directly proportional to the number of significant figures. The number of significant figures. So if you take an example, let us suppose the true value or the original value of a particular quantity is 4.2. Let us suppose. Then, what is the relation between the accuracy and significant figures? So, let us discuss now. So, with an instrument, I have got a value of 4.1. Okay, so here there is a change in the observed value and the original value, and it is nearly 0.1. Okay, and with another instrument which is somewhat more precise, that means if the least count is less, it will be more precise, right? So with that, okay, the value is going to be 4.16. Okay, so here the difference between the true value, that means original value, and the observed value will be, okay, 0.04, which is somewhat very much less than the first value. Then in the third case, with another instrument which is more precise than the previous, okay, it was going to be 4.164. So here the value of error or the difference between the original value and the observed value is very much less than the previous thing. So it will be nearly equal to 0.036. So that means if the precision is more, that means if the number of significant figures are more, then we are getting less error and more accuracy. So that means the observed value is somewhat reaching the original value, okay, if the significant figures are more. Okay, so this was a clear relation between accuracy and significant figures. So you all know that accurate is nothing but if the value is correct or it is somewhat near to the original value, then it is called accurate. So we must have some clarity about the accuracy and significant figures. So then only we can easily understand the concept of errors in this class. Okay, hope you all understood the concept. So let's quickly get on to the concept of errors. So errors. So what is meant by an error? What is meant by an error? An error is nothing but the difference between the original value and the observed value is called error. And there are a lot of causes that are responsible, okay, for getting error in any calculation or in any measurement using an instrument. Okay, so here, before going to the concept of errors, okay, I just want to say one thing. So generally here we will use a word called true value and observed value. So what is meant by a true value? For example, let us consider this box here. So I know the length of this box is, let us suppose, 6 centimeters. That is, the length of this box is 6 centimeters and it is fixed. There is no change in it. So let us consider a 15 centimeter scale. So the word itself means that it is having a length of 15 centimeters. So we have used some instruments to measure that. Okay, So here 15 centimeter is a standard value. There is no change in it. Okay, so this is one type of true value. One type of true value. So another method is there to find the true value. That is by taking the arithmetic mean of all the observations taken in that particular experiment. So to get an accurate measurement, we need to have lot of observations with a particular experiment. Not even a single observed value is not at all enough for us to calculate the value or a physical quantity. So that itself means that we need to have lot of observation, n number of observations. Okay, so if you take the arithmetic mean of all the observations, that means the average of all the observations, so then it is called a true value. So this is the second case. So in the first case, it is a standard value. We know that that value will not change. But in the second case, if you want to find some thickness, or anything, we don't know the value. We don't know the exact value of that particular measurement. Then, if you take the average of all the measurements or all the observations, taken during that experiment, so then we can take that as a true value. Okay, so I think you have understood the concept of true value, and observed value is nothing but the value which we get in the experiment. That is called as observed value. Okay, so here errors are generally divided into two categories. One is systematic error. One is systematic error, and the second one is random error. Second one is random error. So what is meant by systematic error? What is meant by random error? So the name itself suggests a systematic error is nothing but the error that will arise in the system. What is that system? So the instrument which we use, and the process which we do in measuring that experiment, and the conditions that will apply in that particular experiment. So let us explain it in detail. So in systematic error, the first and foremost type of error is nothing but wrong calibration of an instrument. So let us quickly get an example. For example, you all know about weighing machine, right? For example, in weighing machine, before a weight was placed in that particular machine, the value of that reading of the weighing machine must be 0. It must be 0. Then if that 0 be, I think instead of that 0, if the value shows 5 without placing any object in it, it itself means that it will show a wrong value, which is somewhat greater than the original value. For example, it shows 5 and some person stand in it and it shows some 85 kgs. Then what was the original value of that particular person? That original weight of that particular person, it is only 80 kgs, but it shows 85 kgs. So in like this, if wrong calibration exists in a particular instrument, that means instrumental defect. We can say it as instrumental defect. So this type of error is called as instrumental errors, and it comes under systematic error only. That means instrument is a system, right? It's a group of all the parts. That means it is a system. So this is one type of error, that is instrumental errors. Instrumental errors. Second one. For example, if you want to measure the weight of a particular instrument, the first and foremost thing which we need to have is the conditions around it. There may not be more wind or more humidity or whatever it may be. There are some conditions such that it will not affect the measurement shown by that particular instrument. Right? So that means if more wind is coming and if you are using a physical balance, will it show the real value? So that itself means that there are some errors, okay, which will arise due to the conditions like air, wind, humidity, temperature, etc. Okay, so that means it is somewhat taken to be conditional errors. Conditional errors. Okay, and the third and final type of error will be taken to be zero error. So which we will discuss in our next concept called vernier calipers and screw gauge. Okay, so it's zero error is nothing but if the what I said previously in the physical balance, okay, if it shows, okay, the value of 0 to be greater, so what we can say, okay, the initial reading without placing any instrument, any object, okay, if it shows I think greater than 0 or less than 0, so then it will be called as a zero error. Okay, we will discuss it in detail in our vernier calipers concept. Okay, and at last it may not be considered to be a separate, okay, value, I think separate type. So that is human errors. Human errors is nothing but okay, due to carelessness, okay, due to, okay, lack of time management. For example, if I want to, okay, check how many oscillations a pendulum can make in 10 seconds, and I have just used 11 seconds to calculate it, okay, then it is somewhat an error, no? Okay, I just want to calculate the number of oscillations for 10 seconds only, but I didn't check that so-called stopwatch, and I have used nearly 11 to 12 seconds. Will it be the original value? No, no. So that itself means that it is a human error, okay, which will be due to its carelessness or whatever it may be. But in physics, mainly, there may not be that much carelessness by an experimentalist, okay, who is doing that particular experiment. Okay, so to avoid all these things, the first and foremost thing which we need to do is we need to check whether the instrument is perfect or not, or will it have any defect. Okay, so we need to check the first thing, and next, second one, okay, we need to check whether the conditions, okay, that are surrounding that particular experiment favors that particular instrument or not. Okay, so if they need, okay, less temperature to do that particular experiment, if more temperature is present there may not be, okay, a true value, that means exact value, and the accuracy will be less, right? Okay, so we need to check whether the conditions, okay, surrounding that particular okay, instrument, okay, or experimental setup is favorable or not. And the third one is we need to have some clear idea about the process and procedure such that human errors will be avoided completely. Okay, so this is all about the systematic errors, and in the next class, okay, we will discuss about the random errors, definition and its types in detail. Thank you so much.